Hello and welcome to the Land and Climate podcast. My name is Bertie Harrison-Broninsky, and today I'm talking about the space sector with D. Raghunandan, Director of the Delhi Science Forum. Space industries have done a lot of good down on Earth, whether it's technological innovations or strengthened science diplomacy, or the data that we get from thousands of satellites that orbit our planet, which have been essential for climate and environmental research. Less well understood, however, are the potential environmental and climatic hazards posed by future growth in the space sector. What are the risks from increasing quantities of space junk or the rocket emissions from extraterrestrial tourism? And how can we possibly regulate mining on the moon?
If we have that kind of track record on Earth with all its mechanisms and institutions and monitoring and so on, out in space where there's nobody, who is going to monitor what's happening there? If Elon Musk's flight lands in space and he builds a space station, who is going to know what he's doing?
Raghu, as he's often known, has been doing campaign and research work on climate issues for decades, but he started his career in aviation and aerospace technology, and he continues to write journalistically about these sectors. I began by asking him to give us a bit of a background into these two strands of his work in India.
I've been following the climate issues since the first climate conference in Rio way back and since the 90s onwards, and particularly tracking the climate negotiations at the international level. So I and colleagues of mine have been following this issue quite closely, both looking at outcomes of international negotiations as well as what our country, what India is doing with regard to the global problem. The other part of my work with the forum has been on, given my background, my background has been in aviation and aerospace technologies. So given that, I do a fair amount of work in following issues related to aviation as well as space. In that, again, I look at both the international developments and particularly at developments in the space sector in India. Space and atomic energy have been two areas in which India has developed serious self-reliant capabilities to the extent that we can do most of the technological requirements in the sectors on our own. And that is of particular interest to see that we stay down that path and that we continue to invest where required in science and technology, not in vanity projects just to show the might of the country, but in ways that space technology is used both to drive curiosity-driven science as well as applications of science and technology for benefit of society, for human development, etc. And I think so far India has been good that way, but India is now feeling a bit of, I think, the usual international rivalries and competitive pressures. So we are indulging in some of that, the showmanship projects, let me put it that way, projects of lunar travel, landing on the moon, missions to Mars and Venus.
Before we get on to the relevance of these issues to the climate sector, perhaps it would be worth just outlining a little bit more about what is happening within the space industry at the moment. I know you've written recently about India expecting sizable growth in that sector this year and going forward. And of course, with Elon Musk now so deeply tied with the US government, I know the speculation there about what that means for his companies like Starlink and SpaceX. Should we be expecting large growth in this sector, in this industry in the next few years?
Yes, definitely. Space has gone private. And private space will definitely explore and engage in a different set of activities than public space expeditions would have done. Because the private sector is driven, like all private sector activities, that's the nature, is driven by profit. The private sector is not interested in sending a Hubble telescope to find out what's happening on distant planets or to figure out the origins of the universe. Where's the money in that? unless they can figure out a way of selling those amazing photographs to the public and raising money from it. It's not of interest to them because they have a responsibility to their shareholders to generate profits and plow it back. All the space work in India has been in the public sector. And India, being a not very rich developing country, has had a reasonably robust space program, but funded very in a miserly way. Indian space has always worked on a very small budget and wants to maximize what it can get from that small budget. And right from the beginning, India's goal in space technologies has been application-oriented space journey, meaning that you're not undertaking the space travel just to see or just to explore, but to use it for some developmental purpose, to drive some developmental activity and inquiry, which helps the development process. So India has predominantly used space exploration for low Earth orbit activities, from where you can do remote sensing. So you do sensing of mineral deposits, water sources, monitor the health of forests, of crops, agriculture, these kinds of things. Then to supplement or shift away from earlier terrestrial-based broadcast and telecast, just bouncing radio waves off stuff, and then finding that reaching remote parts of the country is very difficult in that. We were one of the first countries, surprisingly, to use satellite for remote education way back in the early 70s. And it was driven by the visionary space fiction writer Arthur C. Clarke, who in fact first advised the Indian government to try and utilize space for communication. There are, of course, many satellites around the world by many international actors, but India now has its own satellite looking at levels of carbon dioxide and other gases, not just around India, but globally, also to study weather phenomena. India has several satellites studying the weather in different parts of the atmosphere. So that is one. The other part is globally, of course, there are a fair amount of observation satellites looking at climate. And that's one way in which I think space is sort of paying back, if you like.
Is there anything else you would like to say about the value and contributions of this industry to climate science, or expected innovations that might be of great use to climate or environmental science?
There are extremely useful inputs that are available through space observation, through observation of the upper atmosphere and of the lower levels in the atmosphere, low Earth orbit. Still, you reach the space, outer space, if you like, in terms of climate as well as in terms of environmental monitoring. What we know about changes of land use, for example, we wouldn't have been able to know purely by terrestrial Earth-based surveying. How many places can people go trudging around on foot and monitor the health of forests, for example, or the health of the oceans? Now, that's a very big area which is being explored nowadays through space observations, is to analyze and look at the oceans, which surprisingly is perhaps not even as well studied as spaces. We know very little about our oceans, including what's happening in the depths. And a substantial part of that is coming to us from space exploration. We are able to understand far more about weather phenomena from space than we are here by terrestrial observations alone, because weather is not just a phenomenon which can be understood with thermometers and barometers at the terrestrial level, but involve huge global phenomena, winds which travel around Earth, interact with atmospheric activities. And a lot of these are today understood from space better than we are able to do terrestrially. We've gained a lot of knowledge of late about loss of forests, not just of shrinking area, but in terms of the quality of forests, which is as important as we've lost so many trees. But what is the quality of the forest cover that we have wherever we still have forests? And to understand that better is also something we've been able to do from space, better than we've been able to do from Earth.
So then when you think of climate impacts from an industry, especially when we're thinking about these large, intensely energy consumption, heavy vehicles, just direct, immediate emissions are going to be the question that a lot of people have, I think. The normal narrative is the greenhouse gas emissions from spacecraft are not significant compared with aviation at the moment, just because of how few launches there are in comparison to how many flights are happening. Is that right? And is there any possibility of that changing, or is that likely to be true for the long term?
No, I think that is likely to change due to, I think, two major drivers are there. The first is what is being called space tourism. Now, if you have actually started driving space tourism, which means people just going up to travel a couple of days in space, or 3 days in space, and have a holiday and look at the stars and look at Earth and the blue dot and enjoy themselves and come back. And those large private space agencies, SpaceX is one, Jeff Bezos and his Blue Origin fleet is the other, and Richard Branson with Virgin Space bringing up the third. Now, all three have said that they are aiming to bring down costs and to raise the number of passengers engaged in space tourism. Now, if that happens, to me, that's a worry. Then your number of launches will certainly go up. It's like the aircraft today. You put in more people, more passengers who want to travel, they'll travel by air. You've got international travel booming. The more international travel goes up and tourism goes up, the more aircraft there are in the air. And the more aircraft there are in the air, it drives up demand further. And there are only very nascent moves internationally to try and persuade people to travel less abroad. So it's going to be the same in space. If it gets cheaper, then everybody will want a joyride and go to space and back. And Elon Musk in particular has been talking in very ambitious terms about his reusable rockets, which will bring down cost. And he's on record as saying he envisages up to 10 flights a day of his spacecraft. That's a lot. And if you've got one guy doing 10 flights a day, and there are 3 big companies doing that, and there's no doubt if there's 3 companies today, and if costs come down, then there'll be 10 or 15 companies tomorrow, each doing 10 flights a day. I mean, then it's going to start causing havoc, not only in terms of emissions and pollution in space, but other activities as well. There are moves going on in terms of changes in rocket fuels and so on to make them less polluting, just as there are in aviation. But there's no denying that there is going to be some pollution. You can't have zero pollution. Even if you drive on hydrogen, you'll still leave behind water vapor, which is also a greenhouse gas. To me, there is another problem which I think is perhaps not been paid as much attention to in environmental circles, and that is space waste. See, in the old days, meaning 10 years ago, your satellites were clunky bits of machinery weighing 10 tons, 20 tons, big communication satellites which would orbit the Earth and relay your television signals or your telephone signals and so on. They were quite typically 20 tons, 30 tons on average. Now, your trend nowadays is to have microsatellites, CubeSats as they are called. There's 1 meter cube satellites. Elon Musk's Starlink satellite constellation going around the globe for satellite-based communications has today got 7,000 small satellites zooming around the planet. Now, each of these satellites has a life of about 5 years. And on average, now that all 7,000 of Starlink's satellites are up, roughly about 1,500 or so of these satellites are going to degrade and fall back to Earth every year. And then you'll need to send up another 1,500 satellites to replace these. Now, when these satellites come through the Earth's atmosphere back to Earth, for safety reasons, they've been designed to burn up in the atmosphere so that they don't land on someone's head back on Earth. But that means that they break up and burn out in space. Now, when they burn out, they leave behind residual matter, which is basically metallic oxides and so on. So that's adding a huge amount of debris and waste gases in the atmosphere. And this is just one company. This is just SpaceX. There are going to be others like that. Everybody wants to get in on the space game and communications. And for them, it is cheaper to send 1,500 small satellites and monitor those than to launch, say, a constellation of 12 large satellites for communication purposes. The smaller guys are cheaper, expendable, you keep doing it, and it works. Making the satellite becomes easier as well. Now, this again is a matter of concern. Is the direction in which innovation is going and the results that it is having in space. Space debris has now become a major problem, which is bits of these large satellites or spacecraft which break up in the atmosphere and are circling. Currently, there are Earth stations run by both the Americans and the Europeans. Every country has its own Earth station monitoring space debris. And it has become so crowded in the atmosphere that even when India, say, launches a rocket, which is once a month or something like that, you actually have to monitor the junk circling the Earth to make sure that there is a gap where your rocket can go and park a satellite in space. And India has really recently launched a satellite, one of whose specific purpose is to monitor space junk, is to keep an eye on other objects in space. And there are other satellites which other countries have set up doing this because there's so much junk floating around that sooner or later one of these objects is going to collide with another satellite, a functional satellite which is in space and damage it, or heaven forbid, collides with a space station and brings the whole damn thing down. It's a problem in space, and when it degrades and falls back to Earth, it leaves behind in space metallic remnants and metallic oxide gases by its process of disintegration and the heat that it goes through. There are mounting problems given the direction that space is taking. And the more the private sector enters space, I'm afraid the more this is likely to happen. Public sector space activities are more amenable to regulation. Private sector activities are not. And there is very low level of regulation currently because the extent mechanisms under the United Nations, etc., are toothless and depend largely on the goodwill of governments who run space programs. Yeah, we'll be good boys and we'll behave ourselves. The private sector is not going to do that. Elon Musk in particular is famously averse to regulation of any kind. He's one of those cowboy capitalists, if you like, who believes in just letting loose everything. Don't regulate. The market will do the regulation required, and that's enough. He's famously been resisting even monitoring and regulation by the federal aviation authorities in the US. He's recently had a blow up of his rocket just above the Caribbean. A lot of space junk came crashing back to Earth, and it is now a rule in the US that if something like that happens, they deny you permission for the next launch until an inquiry has sorted out the reasons for this previous accident and so on. And Elon Musk says this is a ridiculous provision. You should just continue because we know what's happened. We'll handle it. We'll make sure it doesn't happen again. And now he's in government. He can actually nudge Donald Trump to nudge the Federal Aviation Authority to say, we will not regulate this anymore. We will just let it go. So I think we are entering dangerous territory there.
I can totally see the validity of those concerns. I've read some reporting suggesting that part of the reason Musk has disbanded US aid might have been that they were investigating Starlink for other reasons as well. Just on that point about these smaller satellites leaving these waste gases in the atmosphere, I was interested to ask how much we know about the consequences of that. What are the implications of those gases being left behind? And similarly, how much do we know about the other pollutants that are released during rocket launches? I know that chlorine is a concern with the ozone layer, and black carbon and alumina and some other pollutants have been raised as potentially polluting the atmosphere. Has there been much modelling about the kind of atmospheric impacts of these things? Is that still a bit of a grey area?
It's not a grey area so much in terms of knowledge as in terms of the extent. You know, for example, if satellites disintegrate, they're going to or burn up in the atmosphere, they're going to leave metallic oxides behind. You also know that these metallic oxides are going to be, again, a cause for concern regarding the ozone layer because they will interfere with ionization processes, which then result in the ozone deposition, etc. It's not that there is a complete unknown in terms, broadly speaking, what there is. What I think is missing right now is reasonable projection of what's likely to happen if this magnifies and if the magnitude of this increases. Because right now it's relatively small in terms of all the other stuff that's being pumped into the atmosphere from Earth. Unfortunately, most of this kind of research, the funding for that used to come from the US government to academic institutions, from the National Science Foundation. And you can bet your bottom dollar there's going to be no funding for those researches over the next 4 years, certainly.
You've raised concerns yourself about the possibility of extractivism in space, and especially in this context of privatisation. So perhaps you could talk to us a bit about that. I mean, what are the risks and likelihood of mining on the moon and some of these more sci-fi sounding ideas?
Oh, no, not at all. I think that's a very, very real prospect, excuse the pun. But prospecting on the moon is certainly going to be on the cards. There's no ifs and buts about it. Elon Musk has declared that that is his reason why he is in space. He wants to go to the moon. He wants to establish a space station on the moon's surface in order to start doing mining and exploration and extraction on the moon, and then use the moon as a stepping stone, as a base from which to shoot rockets towards Mars and other planets, because it's going to be cheaper to launch from the moon than to launch from Earth. So that's his plan. He's articulated it very strongly. The US has backed it in terms of what they call the Artemis mission, in which space launches by the private sector are going to be the main driving force. And the Elon Musk's space launch vehicles by Boeing and others, are directed towards precisely this aim of being able to set up a station on the moon. And the public sector and universities may be interested in observations and studies, but the private sector is very clear that they are going to go for exploration. Now, what is important to note is earlier we had in the world, and we still do, we have a space regulation. It's an agreement which all countries have come together under the aegis of the United Nations, which has spoken about essentially using space for the universal public good. That's basically the idea of that. Now, the US has developed this Artemis mission and a set of goals that it has, which spells out that there is no difference between the state public sector and the private sector. So it means that the private sector also will participate in these activities. But there's a rider there. The rider is that earlier, if there was some extraction done on the moon by the public sector, it would be for the common good, meaning the planet as a whole would share from that exploration activities. Now, if a private sector investor has reached the moon and starts extracting, the policy of the US today allows the private sector to exploit it, supposedly for humankind, but obviously it's going to be for the benefit of that company. And because of the power of the US, with the Artemis program, has invited other countries to be part of that program, including Britain, including the Europeans, including India and others. And many countries have signed on saying, yes, we want to be part of this, which means now there's a growing block of countries, all of whom now are pledged down the road to see that private sector exploitation and extraction on the moon is permissible. And given the state of play in terms of regulation on Earth, who is going to regulate what's happening on the moon? Which is that agency? The UN does not have a mechanism yet. It depends on collective goodwill. But today, the US can just walk out of any United Nations body, can cock a snook at the UN and say, we don't care what you regulate or not. We are there. We've got our rocket. We have put money in it. And it's our right to take stuff back. Who is there to stop us? And if one company goes in that direction, obviously other companies will follow as well. India, for example, adopted our own space policy just a few years ago. And we have incorporated clauses drawn from the American framework and incorporated that into our policy as well, supposedly in order to encourage the nascent Indian private space sector and to encourage them to go in this. I am extremely worried about this, that the more you encourage the private sector activities in space and the less you regulate those, you are asking for trouble. We have not shown great responsibility on Earth in terms of ecological preservation or conservation. We have, in fact, gone the other way. We have driven our planet as close to self-destruction as we can. When I was growing up and as a student, we thought the end of the world would come because of nuclear weapons. Now it looks as if the end of the world is more likely because of ecological destruction. That's the track record that we have. And if we have that kind of track record on Earth with all its mechanisms and institutions and monitoring and so on, out in space where there's nobody, who is going to monitor what's happening there? That's a major concern. And we are already facing this problem in the Arctic. Now that the polar ice is melting, it's opened up the polar region to exploration. Ships are able to go through the North Pole now, and vessels, not just from the northern countries, from Europe, particularly from US, Canada, and Russia, but vessels from China are going to the North Pole because the North Pole is no man's land. It belongs to nobody. Or to put it the other way, might is right. So whoever has the money can send ships, start exploring, digging for oil, digging for minerals. The same thing is going to happen in the southern pole. It's already starting happening in the deep oceans where regulation is very thin. I would like to see greater emphasis on re-examining the International Space Treaty under UN aegis and to strengthen monitoring mechanisms internationally, which is going to be a tough ask if powerful countries like the US resist it. But unfortunately, today what's happening is other countries are very quick to jump on the US bandwagon. To my mind, this is a far greater danger, at least to the extent that we know now, than the ecological danger posed by space within Earth and its atmosphere. Although, as we've discussed, that could get bad as well.
My thanks to D. Raghunandan for coming on the show, and to Vasco Kostovsky for our audio engineering. As always, we've put some further reading in the podcast blurb, but you can find a lot more on our website at www.landclimate.org. Please do like or follow or subscribe to this podcast. If you found it interesting, share it with friends or colleagues. We really appreciate your support. Alistair will be back in 2 weeks to hear about how big corporations are able to sue developing countries' governments when they try to decarbonise. Until then, goodbye, and thanks for listening.